Hello, our next presenter within the Automation and Workflow group is Daniel Juchley from the CELA Consortium.
Hello, my name is Daniel. I'm from wega, and I'm going to talk about how a digital lab should actually look and feel like today. And this presentation is thought to be a inspiration on how you can actually start on your digitalization path. First of all, I'd like to thank Future Labs Live for making this conference possible. And I'm going to start with a very brief introduction of wega, so the company I'm working for, and then I'll actually right away start into and we'll dive into the topic. So wega's vision is to build a bridge between business and IT, and we see ourselves in the middle of that bridge between the life science business and the informatics departments, and we do have most of our employees with double qualification, so as a chemist or biologist or bioinformatician, etc., and the required IT background or education. And by being on that bridge, we can actually work as a 360-degree service provider in pharma or more general life science and also healthcare informatics business. We are organized around 4 pillars of excellence. So we do have a team that focuses on lab and research informatics. We do have a team that focuses on clinical development informatics. We have a department that provides the informatics solutions to the 2 domains I was just mentioning. And we also have a computer system validation and quality assurance team. And with this, we are able to help you with, for instance, starting by doing a analysis of your landscape and propose new systems or how the system landscape should look like to you. We help you do process analysis, requirement analysis. If you, for instance, like to select a new LIMS system or an ELN system, or also a clinical trial management system for your clinical trials, etc. And we do have the appropriate education and know-how inside the company with business analysts, project managers, and experts in all these areas. And just to give you an example, maybe you do maybe have a LIMS which is already like 10, 15, or 20 years old. You like to replace that. What we do is we probably start with analyzing the business processes, creating a as-is view, and starting to shape the to-be view together with you, with involving our knowledge of the landscape of vendors, etc., and then finally help you shaping the requirements document, doing the RFP, helping you finding a vendor, and finally also maybe if you want help you to implement the system, decommission the old system, do a data migration, and also accompany yourself with the validation of the system with our CSV folks, and also in addition maybe with our technical folks if it's about implementing a specific interface or device integration or whatever, where we do help with our technical folks in that very project. So why would you work with wega? I think it's especially our dual qualification and the combination of the scientific and informatics skills, which is quite unique. Our experience, we're more than 25 years in business, successfully and independent. We are neutral in terms of vendors. We do know all the main vendors in our areas, and we also have strategic partnerships with many of these vendors, but they're non-commercial partnerships. And I think this is very important that we do have that neutrality and can help you in these areas. And we also work a lot on innovative initiatives, how to use blockchain in serialization, how to apply blockchain technologies for securing a distributed audit trail, for instance, how to bring agility into non-agile environments, etc. So this is all our bread and butter, really, where we do have loads of experience. We're currently a bit more than 100 employees, with a headquarter in Basel and a subsidiary in Germany. And we also do have employees in Poland. Okay, now let's dive into the topic. So how a digitalized lab should look and feel like. This is, as I said initially, really thought to be an inspiration. We're not trying to sell you a product or an informatics solution or a hardware product. We like to show you what's important in our view on your journey to a digitalized lab. And of course, we will have a bit of a focus as well on what standards play as a role in this journey. But it's not only that, you will see that right away. So what is digital transformation in a lab? Talking to different people, you get different opinions, way different opinions. People see many different aspects of digitalizations. Depending on who you talk to, people might think about, okay, this is automation, this is robotics, really lab robotics, lab automation. Others maybe think more about, okay, I'd like to automate the data flow, sample processing. I like to automate the decision or monitoring process, tracking and requesting, etc. Yet other people might think about, okay, the digitally transformed lab is accessible, everything's online, there is collaboration tools, etc. It's just everywhere, data is available everywhere. Yet another group of people will think about connectivity, so everything's plug and play, integrated, and last but not least, there is data integrity topics that are interesting in that connectivity context, and everything's reliable. And also, other people might think about, okay, the digital transformation in a lab leads us to an intelligent lab, which employs machine learning algorithms and artificial intelligence to actually help you do the work. Now, we believe, yes, everything's right, maybe, but we actually took it from another perspective, and we thought, okay, what is the required foundation to actually do a successful digitalization? We believe the foundation for success is, of course, from a technical perspective, a proper architecture with integration layers when talking about connecting systems, connecting instruments, connecting devices, etc. And of course, we also believe it's very, very vital that you do proper use of standards like SILA, standardization in lab automation, NEML, analytical instrument markup language, and BPMN. And also the focus, and this is last but not least, the focus on user experience and usability. I think this is a very important aspect, and we believe that the successful path to digitalization is actually based on all these three things that are listed here. I'd like to dive into these three aspects a bit more and just highlight a few of our thoughts and how we see that, and try to explain why we believe that makes a lot of sense like that. Let's start with the architecture. This is an example of how a architecture of an integrated digitalized lab might look like. And I don't want to go into details of all of these layers. I'd really like to focus on this integration layer, as we believe that the integration layer is a key component on your journey for digitalization. You see a lot of familiar terms probably on the enterprise application layer. You see a lot of familiar terms in the device layer, I believe. And you probably can also understand the data analysis layer, so what you can actually could do once you have acquired the data and want to find a path towards knowledge. But the integration layer is vital for a successful digitalization of your lab. And the main purpose of this layer is, of course, decoupling of the system. So this is not really new and not maybe very interesting. There is a lot of like enterprise service buses and systems like that do the proper decoupling. But I think it's important that you do that. And then there is workflow orchestration. And then maybe you might think, okay, what is workflow orchestration now if you compare that maybe to an LES system, to a laboratory execution system? And what we mean here by workflow orchestration is really a lower granular or finer granular workflow orchestration. Just think about a LES system which executes a method in a lab, and this method would contain a sample preparation step. The sample preparation step would maybe have some input parameters and some specifications, but actually the execution of the sample preparation step would involve maybe 2 weighings and a pH adjustment and maybe a dilution step. And this is the level of workflow orchestration that we see in the integration layer, where it just maybe makes sense to do that at a lower level because the LES system is just too far away from the actual instruments and of the actual control. But very, very important, maybe yet the most important part is the standardization. Latest on the integration layer, you should start with the data standardization. Yeah, there is a zoo of different instruments and different data formats down here. And latest on the integration layer, you should start standardizing your data into a standardized format with the appropriate metadata attached to it. And of course, you can also do it down here. I mean, it's even better if your photometer already delivers standardized data, then you don't have to do it up here. But latest in the integration layer, you do have to do that. And I think just thinking this way and along these lines from an architectural perspective helps a hell of a lot to actually create a great foundation for digitalization. This is just listing a few of the things that you maybe get in addition, or maybe not so obvious. But of course, with this type of architecture, you get very high data availability. You can be very agile and you can get to faster decisions. This architecture is super scalable and very flexible at the lower cost of ownership in total. And you also make yourself independent from vendors. Of course, there is many different vendors involved here, but the whole architectural picture doesn't depend on one single vendor. And integration of lab standards, I come to that, is definitely a very good base, right? And then there is a lot of other things that will come into the future. I think labs will more and more make use of cloud services that have to be integrated into a local architecture. And then again, standards play a very important role there. Okay. And also, I mentioned that the workflow orchestration, the ability to capture metadata at the source, basically, and then make advantage of the enabling standards. Now, the driver, I mentioned standards a lot now. I mentioned connectivity and data standards, and I want to dive a bit more into that. And this sentence here maybe is very interesting if you compare that to, okay, I have a friend in a lab next door. He wants to share spectroscopic data with me, but I can't actually look at it because I don't have the software that was used to do that spectrum. So I think this is a very clear illustration why standards are so vital and so important to be present also in our industry. Now, to actually make the full use of the architecture I've been showing a few slides earlier, we need to have standards that enable the connectivity and the data. I said that. So basically, you have many systems, instruments, devices, electronic lab notebook, LIMS systems, whatsoever in your lab. And these things have to be able to find each other. These things have to be able to describe the capabilities so that another system can make use of yet another system. And then there needs to be standards to actually orchestrate and command these different services into a workflow. So it's very obvious that the standards are the foundation here. And once you have that, you can also do these fancy machine learning and artificial intelligence stuff on top of that, but not before, right? That's, I think, one of the key messages and of the take-home messages here. Now, talking about standards, I mentioned it before as well. Communication standards, I think there is almost no way around CELA. CELA is the only standard which is established in life science for life science communication between services and systems. Some of you might have heard maybe of OPC, but OPC is really suitable for industrial automation and not made for the type of interaction models and data that is actually coming up in labs. And then data standards, the analytical instrument markup language is definitely the way to go. Maybe you have heard of Allotrop as well. If you compare these two, they cover basically a very similar use case, but we want to focus on animal here just due to the business model and the openness. Animal is like CELA, free of royalties and licenses, and it's a very accessible format, which has, as CELA, has a very low total cost of ownership, and therefore it's just very much suitable for that case. And then for the workflow orchestration, there is a business process modeling notation, BPMN, which is extremely widely used, and it makes a lot of sense to apply things and just steal things from other industries that work well, right? Now, the last point, remember I had three things: the architecture, the use of standards, and the user experience. I think this is often forgotten, but I believe it's very, very important. We have to bring the user interface close to the user. If you think about the user in a lab, that user focuses on the lab work. That user is not interested to work on a PC. Very often, a tablet cannot be used in the lab due to gloves or the chemistry. Very often, there is not enough room for a PC, right, in the lab. So it's vital that you bring the SOP directly to the instrument, that you have a full user guidance directly to the user, at the user. And therefore, we created the so-called digital lab in a nutshell to actually make this whole thing, the architecture, the standards, and the usability very, very tangible. We actually created small instruments that basically in the background, they are driven by Raspberry Pis running on battery. They all have Wi-Fi built in, and they all are CELA servers that provide CELA services over the network and support the animal standards. And why have we done it like that? We wanted to have something that we could just bring along to show, and that's why we did not use like real devices. And they also wanted to be able to carry around these things without breaking an analytical balance, etc. Yet still, all these instruments actually work. They are analytical instruments that work and have a function, and the workflow can actually be shown. But you also see that all of these instruments have a touch screen. They have visual and haptical feedback. So you can basically directly at the user in a lab notify the user when to do what, right? And the user can really focus on the lab work. And we will be able to demo that to you. So anybody of you is interested in seeing that demo, just ping me, please. Or put the question into the question box, and then we get in contact, and we will be able to show you that demo live in a maybe 1 hour session online, and interact with you and discuss how these things works. Just a few impressions of the whole thing. So we're actually using a so-called CELA browser here, which is a kind of a digital twin for the physical instrument that you see on the left. And then, yet these different physical instruments, they're all CELA services. They can be put very easily into a workflow using the business process model notation. Also here, what we used is an openly available Camunda-based BPMN workflow execution that we just enhanced with the CELA support. And now we can do a graphical, basically drag and drop creation of your workflow and actually run that then right away. This is yet another impression of the balance. And also when you can monitor data, record the data, etc. I think this is what I wanted to show in this 20 minutes, very short. I'm here also in the chat for you to answer questions, etc. I'm happy to take questions. And as I said, also happy to take requests for demos. So please feel free to contact me in case of questions and if you're interested. Thank you very much for your attention and enjoy the rest of Future Labs Live. Thank you.